On this problem, we're going to use Kirchhoff's voltage law to find V1 and V2. So we know that if we apply Kirchhoff's voltage law around this loop, we're going to have a current I sub x that flows through all the elements. So Kirchhoff's voltage law then will give us that source voltage is going to be equal to V1 plus V2. Ohm's law says that V is R times I, so that means that for this particular case, our source voltage then is going to be equal to R1 times I sub x plus R2 times I sub x. The subsource then is going to be equal to R1 plus R2 times I sub x. If I solve for I sub x, this is going to be source voltage divided by R1 plus R2. So that now I can solve for what's the voltage across V1, and this is going to be equal to R1 times this value of I sub x that I found right here. So this is going to be R1 times source voltage divided by R1 plus R2. Now, that's V1. Why did I assign this polarity? Well, using passing sign convention, I know that when the current enters an element like a resistor, then we assign a positive to the terminal where the current enters. The same will be for R sub 2. Current enters this resistor R sub 2, so a positive sign will be at the top, and then this will be our value for voltage V sub 2. Voltage V sub 2 is resistance R sub 2 times the current that flows through the resistor. And that current is what we found over here, so it's going to be R2 times the source voltage divided by R1 plus R2. So if we look at the steps, this is 1, 2, 3, 4, 5 steps to find these two values. Now we're going to learn an easier way, and this is going to be voltage division. And voltage division says that the voltage across a resistor in series in a path will be equal to the product of the selected resistor multiplied by the voltage source and divided by the sum of all the resistors on the path. So if I want the voltage across R sub 1, that's V1, then I need to look at the selected resistor, multiply that by the source voltage, and divide that by all the resistors on the loop. And that's R1 and R2. That will give us V1. If I want to find the voltage across resistor R sub 2, then following the rule, the selected resistor R2 must be multiplied by the source voltage and then divided by all the resistors on the loop. And that will give us V sub 2. So the voltage division will express it in a more general way. Will be something like this. The voltage across a resistor in series in a path will be equal to the product of the right resistor, in this case is R sub 1, multiplied by the source voltage divided by the right plus wrong resistor, and that will give us the voltage V1. Also, the voltage across R2 will be equal to the right resistor. In this case, since we're looking for voltage across R sub 2, the right resistor will be R sub 2 multiplied by the source voltage divided by the right plus wrong resistor. Let's then try on this example with 3 resistors. We want to first do this with Kirchhoff's voltage law, and so we're going to assign a current I sub x in this direction, and we know that this current is going to be equal to total voltage, source voltage divided by total resistance R1 plus R2 plus R3. So that if I want to find the voltage in V1 and I am assigning this polarity because the current is entering in this way. So this will be the polarity for Bishop 2, and this will be the polarity for Bishop 3. Then Bishop 1 is going to be equal to resistance times current I sub x. So it's going to be resistance times source voltage divided by R1 plus R2 plus R3. Bishop 2 then will be equal to R2 multiplied by the source voltage divided by R1 plus R2 plus R3, and Bishop 3 will be equal to R3, the right resistor, divided by R1 plus R2 plus R3 times the source voltage. Now, let's apply voltage division to this particular problem. For voltage divisions, what we want to do is reduce this network to a two resistor network, where I'm going to call this the R equivalent, and this is going to be my resistor, the right resistor or the selected resistor. So if I'm looking for the voltage V sub x, or the voltage across the selected resistor, that in the first case I'm going to do for R sub 1, R sub x being R sub 1, then and voltage division in this particular case says that the voltage V sub 1 across the selected resistor or the right resistor will be R sub 1 times the source voltage divided by all the resistors on the loop. In this case will be R1 plus R equivalent. Now, what is R equivalent for this particular case? Well, R equivalent will be the combination of these two resistors, R sub 2 plus R sub 3, so that V sub 1 is going to be R1 times V sub source, R1 plus R2 plus R sub 3. And if you can see, this is the same result as the one above. Now, if I want to make R sub x now equal to R sub 2, meaning that I'm going to select this resistor, I want V sub 2, then the rule says that the selected resistor or the right resistor, that is R sub 2, must be multiplied by the source voltage, and it has to be divided by the right resistor plus the wrong resistor, that in this case is going to be this resistor and this resistor combined in an equivalent resistance. It is going to give me R sub 2 times source voltage divided by R2 plus R1 plus R2. And again, if you can see, V sub 2 here and down there are the same result, but this one was using voltage division and this one was using just Kirchhoff's voltage law.